Hello and welcome to this video on running compression. The purpose of this video is to assist you in being able to identify all the events that take place in a running compression waveform. Now before we take a look at a live waveform and how to analyse that waveform, we're going to take a quick look at how to set up the hardware that's required in order to carry out this test. Therefore, if you take a look at the video in the bottom right hand corner of the screen, you can see that I'm using the WPS 500 pressure transducer and that this has been connected to cylinder 1 of the engine. Now in terms of setting up the transducer, all we need to do is simply turn the transducer on, allow it to go through the self-calibration process, and once this has completed, we just need to ensure that it's set to range 1. This is because we could be looking at pressures anywhere from 20 all the way up to 34.5 bar. Now in terms of running the test, we do need to ensure that no fuel can enter the cylinder in which we're testing, and in most cases this can simply be done by disconnecting the fuel injector. We also need to ensure that we can isolate the ignition supply from that cylinder, and if we're working on a vehicle with a COP ignition system, this can easily be done by disconnecting the COP unit and removing it from the engine. If, however, you're working on a distributor or a disc type ignition system, then what we need to do is take our HT cable and connect this to a suitable ground point on the engine, as this will ensure that no damage will occur to any of our ignition components. Now what I'm going to do is I'm going to start the engine up so we can look at a live running compression waveform. Now if you take a look at the waveform on the screen, you can see that I also have my injector signal and I also have my secondary ignition signal, and the reason I've done this is so it can help us identify all the events that are taking place and the timing of those events. Now to get a better idea of what's going on, I'm going to load up a waveform that I took earlier in which I've added some detail and some events on that, so I'm just going to go ahead and load that up now. You can see by looking at this waveform that I've identified the piston position by putting TDC and BDC across the top of the screen. You can also see that I've identified the 4 stages of the cycle, i.e. power, exhaust, intake and compression. You can also see that I've tried to identify the valve opening times, so we've got our exhaust valve opening and closing and our inlet valve opening and closing. So if we start now to analyse the signal, we can see that if we start on the left hand side at top dead centre on our power stroke, we know that our piston is going to travel all the way down to bottom dead centre within this process. And we can see that during this process that our pressure has reduced, and this is as a result of the piston movement. We can also see that our pressure returns to a negative pressure, and this is because that no combustion has actually taken place, and we're essentially looking at the cylinder as an air pump. Therefore the pressure we started with should be the pressure that we end up with. Now if when you come to carry out the test you end up with a lower amount of depression, i.e. a slightly higher pressure, this could be that one of our valves, i.e. the inlet or the exhaust valve, or maybe even our piston rings, aren't sealing properly and we've leaked out some of our air. We can also see that towards the end of this cycle that our exhaust valve has begun to open, and we can see this by our pressure starting to increase up to 0. If we take a look at the exhaust stage now, we know that our piston's at bottom dead centre, and then it's going to travel all the way up to top dead centre. We know that our exhaust valve is fully open, and what we can see here on our compression signal is that we have these ripples taking effect. Now these are caused as the piston's travelling up the cylinder and it's pushing all the air out through the exhaust valve. We can also see that towards the end of the exhaust valve that our inlet valve has begun to open, and we have this period of valve overlap. This then takes us into the intake stage of the cycle. We know that our piston now is at top dead centre and it's going to travel all the way down to bottom dead centre. We can see that we have these ripples created again, and this is as air is being induced into the cylinder past the intake valve. We can also see that our exhaust valve is now fully closed and our intake valve is still open, and we're inducing air into that cylinder. This then takes us into the compression phase, in which the piston is now at bottom dead centre and it's going to travel all the way up to top dead centre. We can see that our intake valve is closing, and then after this we can see that our pressure begins to build back up, and this is because the piston now is compressing the air in the cylinder as it rises back up to top dead centre. Then essentially the cycle repeats itself, and this is how to interpret a running compression waveform. Now what I'm going to do is I'm going to pull up the waveform again, the live one, so we can take another look at that. You can see that my pressure now is around 5.8 to 6 bar. You may be thinking that this doesn't tell us the correct pressure of what the cylinder is able to produce. So I'm going to show you now how we can get that information. So what I need to do is I need to just slightly tweak this waveform, and I'll talk you through what I'm going to do. I'm going to remove the injector signal as we don't need to see that anymore. I'm also going to remove the secondary signal as we don't need that either. I'm going to change the setting for the transducer, as now we're going to be looking at a much higher pressure. So I'm going to go for the full range, up to 34 bar. I'm also going to bring in channel D, because I've connected this up to the mass airflow meter. I'm going to set this to 10 volts, so it gives us our 5 volt range on the top. What I'm going to do now is I'm going to change my trigger. So I'm going to move the trigger threshold up to 10 bar. So you can see now we're not triggering on anything. I'm going to change this to single capture. And I'm also going to change the time base now to a much longer time base, so we're streaming. I'm going to go for 1 second across the screen. You can see now that we're streaming. I'm just going to bring the trigger over to 30%, so we can capture the whole event on the screen. And I'm just going to make sure that I've got filtering on my mass airflow meter, as we do know that this is a dirty signal like lambda and map, and that our output could be slightly noisy. And there we go. So I'm just going to activate the filtering now. I'm just going to bring the video feed back up so you can watch as I go wide open throttle. And then what we're going to do now is we're going to go wide open throttle, and this should tell us the maximum pressure that this cylinder is able to produce. You can see that the engine didn't quite like that. However, we did achieve a pressure of 24, just under 25 bar. So that tells us in terms of the cylinder what it's able to produce. Now I hope this video has been of some assistance and helps you to understand the running compression waveform and how to get a maximum pressure reading out of a cylinder. And I thank you for your time. Thank you.